The diagram shows part of the curve with equation y equals to 12 over cube root of 2x plus 1. Okay, and then the point A on the curve has coordinate 7 over 2, 6. This is 7 over 2, 6. I'd like to write it myself. So, to be clear about what the question wants me to do with the diagram. Find the equation of the tangent to the curve at A. Right? Equation of the tangent. Tangent is going to be just a straight line. Means that you have to write it in terms y equals to mx plus c. Which means you will need to find out the gradient. Okay, how do you find the gradient? You are finding the gradient, if you can recall, it is by differentiating the equation. You have your y equals to 12 over cube root of 2x plus 1. Right? And I would like to write this as 12 times 2x plus 1 to the power of negative 3. Sorry, negative 1 over 3. Okay, negative 1 over 3. Because it's at the denominator and because it's a root of 3. Root of 3 is 1 by 3. Okay. Next step, I would be differentiating that equation. Finding dy over dx is simply 12 is a constant, and then again you multiply with the power, which is negative 1 over 3, and then you differentiate the one inside the bracket, which is 2, and then you rewrite whatever you have in the bracket. The power would be minus 1, so you'll be having minus 4 over 3. Okay, simplifying this, you can divide 3. You can divide 12 and 3 here. You'll be having 4 times 2. So you have negative 8, 2x plus 1 to the power of negative 4 over 3. Finding out the gradient at exact point means that you have to substitute. That is when x is equal to 7 over 2. When x is equal to 7 over 2, your derivatives of your gradient is equals to negative 8 times by 2 times 7 over 2 plus 1 to the power of negative 4 over 3, which should give you negative half. Okay. Now, that is not yet an equation, that's just a gradient. How do you work out on the equation? Equation is just y minus y1, in this situation is 6, equals to m x minus x1, which is 7 over 2. Again, y minus y1 equals to m x minus x1. Okay. Once you write this, you're actually done.